Hello everyone, today we're going to be going over the integral of e to the x sine x. So this is a bit of a tricky one actually, in my opinion. And the reason for that is you've got to, it's more than just doing blind calculus. It's more of a thought process that's involved in this, but it's not too bad. So let's get on with it. So before we get started, you've got to be familiar with this, and you've got to have done a few examples on it as well, and you have to be comfortable with using this, because obviously to integrate this we have to use integration by parts. So make sure that this is fully understood. Okay, so yeah, without further ado, let's begin. So we're going to start off by defining some variables, okay? So yeah, let's begin. I said that twice now, didn't I? Yep. So the integral of e to the x sine x is equal to, well, first we've got to define our u and our v. Which one shall I pick? Yeah, I'll pick u equaling e to the x and dv dx equaling sine x. That will imply for the e to the x thing, it would be just e to the x, because when you differentiate an exponential, you get the exponential back multiplied by the constant term. In this case, the constant term is just 1. So yeah, we just get e to the x back. Now we integrate sine x. We're going to get minus cos x. All right, so v is minus cos x plus a constant of integration c, but let's not worry about that too much for now. Okay, we'll get back to constants later. So u dv dx is equals to uv minus v du dx, right? So uv in this case, well, we already know what u is, that's e to the x, and we found out what v is actually, so that's just minus cos x, and then minus the integral of v du dx. So yeah, v we already know is minus cos x. Du dx, on the other hand, is, well, still e to the x, isn't it? So then we're going to get minus e to the x cos x plus the integral. Yeah, because look, I'm taking the minus sign outside, minus times a minus is plus. So yeah, minus e to the x cos x plus the integral of cos x e to the x. So when we integrate cos x e to the x, we've got to do that v du dx thingy again, don't we? So that's cos x e to the x cos x. Now I'm just going to do it in my head actually, but we just follow the same procedure as before, and that is just yeah, differentiating and integrating for v and differentiating to find u. So uv e to the x, and now when I integrate cos x, that just gives me sine x back, right? So oops, I need to put my other terms there first. Minus e to the x cos x plus e to the x sine x, yeah. So that's my uv minus v du dx. V in this case is sine x, du dx, well, that's just e to the x again. Well, hey, happy days, eh? Happy days. Mind you, this is being integrated again, sorry. Right, so at this point, if we carry on doing this, we're going to go on forever, alright? It's just not going to end. So in order for us not to go on forever, we need to understand this, alright? So the integral of e to the x sine x, I forgot my dx there, and there, and there, oh god, and there too, but it doesn't really matter too much. So we've got that, and now we've worked out everything. So we worked out that bit as being equal to this stuff here. So minus e to the x cosine of x plus e to the x sine x minus the integral sine x e to the x dx. Alright, so we know that to be a fact. So let's rewrite that out more neatly. Right, so what you can do here is you can add this guy here. So you can add this guy over to that side. And because they're the same, obviously, so you can do that. That'll give you 2 lots of the integral e to the x sine x dx equals minus e to the x cos x plus e to the x sine x. And because I can in this situation, because look, if I move all these terms to one side, I can get that equal to 0, which means I can multiply each side by the same term. So in this case, what I'm going to do is I'm going to multiply every term by a half. Okay, so if I multiply this side by a half and I multiply this side by a half, what you'll notice I get is 2 over 2 is just 1, so just write that as the integral of e to the x sine x dx equals to minus e to the x cos x plus e to the x sine x over 2, and that is your answer. If we really fancy and, you know, just be a little bit extra, which there's nothing wrong with actually, just write it with the positive terms first and then the negative terms later. So there you go. Yeah, I'm pretty proud of that. Yeah, that's it. That sums up everything. So if you have any more requests for tutorials, as usual, you know, just let me know in the comments down below. I'll try my best to help you out. But yeah, that was the integral of e to the x sine x. It's a nice little way of doing things, you know. We'll go over the cos x one next. I have this habit of just going through very niche integrals and differentials, but it helps you guys out, and, you know, it allows me to target a more niche audience. It's easier for me to build up, and, you know, there's nothing more frustrating than not knowing something, and then you Google it, and there's a very specific tutorial on. It's like, oh my god, it's there. I've got something, you know, and I hope to be able to provide that sort of satisfaction, and if I am, then that means a lot to me. So yeah, that's about it for this one. Do forgive my nerves. I do get a bit nervous as of right now because I am new on this platform. But yeah, that's all I've got to offer you. Take care. Have a good day. Bye.